We made it to the end of chapter 6. This is day 8, systems of inequalities. Similar to yesterday, except in the last two examples, we're going to have to get into slope-intercept form, which is something we've done before. So these first two are just like the ones from last lesson. So our first line, it's already in slope-intercept form. Y-intercept is -2. Slope is up 5. 1, 2, 3, 4, 5. Over 2 to the right because it's positive. Line would be solid because it's also equal to, and then we want to be below that line because it is less than. And I'll graph the second line. Y-intercept is +2. Slope is 1/2. So up 1, right 2. Same thing as going down 1, left 2. This line is also solid because it is equal to, and I would be above this line because it is greater than. So then the space that is below the red and at the same time above the green, below the red, above the green would be right here. Similar on number 2, first line, y-intercept +2, slope is -1, right? Just graphing a line like we've been graphing lines in numerous different topics. Solid because it is equal to, right? And this one's greater than, so I want to be above this line. Second line, y-intercept is -2, slope is -5, so I can go up 5. I go to the left one to make the line fall because it's negative. Solid because it's equal to, I want to be below that one because it is less than. So if I'm below the green, let's see here, below the green at the same time above the red, I'm in this area right here. So remember, the shaded region would be the infinitely many points that work for both of those inequalities. All right, so you can see the difference here on number 3 is they are not in slope-intercept form. So that's what we have to do first. So we have x plus 2y greater than or equal to -6. So to get in slope-intercept form, to solve for y, I would subtract x on both sides. So I have 2y is greater than or equal to -x minus 6. To get rid of a multiply by 2, we divide by 2. Remember, there's an invisible 1 in front of that x there. So we have y is greater than or equal to -1/2 x minus 6 over 2 is 3. So I can see the y-intercept then, just like yesterday, is -3. Slope is -1/2. So up 1, left 1, down 1, right 1. Solid because it is also equal to, and above because it is greater than. So then I go the second inequality. 5x minus 2y is less than -6. So to get rid of 5x, I would subtract 5x on both sides. So I'm sitting at -2y is less than -5x minus 6. To get rid of a multiply by -2, I divide by -2. And remember, inequalities, if you multiply or divide by a negative, you have to flip the inequality. So this becomes y is greater than -5 over -2. The negatives would cancel out. We have 5 over 2x. -6 over -2 is +3. So y-intercept is +3. I'm going to have to go down 5 to stay on my graph. So I go 1, 2, 3, 4, 5. To make it rise, I would go left 2. This one would be dashed because it is not equal to, and I want to be above it because it is greater than. So above the green and above the red puts us right here. Same thing here on the last one. Neither one of them are in slope-intercept form, so that's the first step. We've got 2x plus y greater than -3. So to move a +2x, we subtract 2x. So y is greater than -2x minus 3. So y-intercept is -3. Slope is -2. So I can go down to right 1 or up to left 1. This would be dashed because it is not equal to, and it would be above that line because it is greater than. Second line, x minus 2y is greater than -4. To move an x, we subtract x. So we have -2y is greater than -x minus 4. To get rid of a multiply by -2, we divide by -2. Again, dividing by a negative makes me flip. So So y is less than, invisible 1, negative 1 over negative 2 would be 1/2 x. Negative 4 over negative 2 is positive 2. So there we start at positive 2. Slope is 1/2, so up 1, right 2, or down 1, left 2, because the slope is positive, the line should rise. Dashed, because it is not equal to. And this one was less than, so I want to be below that one. So if I want to be above the red and at the same time below the green, I would be right here. And remember, any point in that blue shaded region would work for both of those inequalities.